In this video, I'm going to show you a couple of things that you need to do the Hooke's Law and Conservation of Energy lab. One of these is to record data as events rather than as a continuous stream of data over time. But before we do that, we're going to make the graph look pretty at the end by not connecting the data points automatically as they are plotted. So I'll double click on any of the graphs, and it brings up graph and axes options. One graph option is to connect the points. I will now deselect that so that I'll have my points individually plotted, and the only line that will be put through them is when we do the fitting, when we fit the line to it using our curve fitting programs or the curve fitting tools. So I hit OK. Secondly, I have to set the data to be collected as events. So I go under the experiment menu, click on Data Collection, and instead of our familiar and much loved time-based mode, we're going to pick Events with Entry. Now our independent variable here is discrete. We're going to be putting discrete masses onto the hanger connected to the slinky. So mass will be my variable name. The short name will be capital M, and I'll use grams as my units. We will convert to kilograms later on. So now I'm done. And we notice that this new button appears next to our familiar green data collection button. This is the Keep Current Value button. You'll hit that button when you have a value measured that you want to actually keep and store in the data record. So we're going to go ahead and get started. Right now, I have just my 50-gram hanger sitting on the slinky. And I'm going to go ahead and press the green button and start the data collection. But nothing is actually being stored yet. The motion sensor is simply sensing the height of the hanger above the floor. And you can see that as I move the hanger, the position of the hanger is recorded. But this is actually going to be my first data point. I have no extra mass, just the 50-gram hanger. So once things have settled down, I'll click on the Keep Current Value button. I'll type in 50 grams, hit OK, and now I have a stored data point over to the right. I'm going to add 10 more grams. Again, let it settle down, and again click on the Keep Current Value, and this time I'll put in 60 grams, 50 plus 10. And I'm going to continue doing this until I have data points from 50 to 100 in 50-gram increments. Okay, that was wrong. What I meant to say was I'll get data from 50 to 100 grams in 10-gram increments. And now we need to actually convert grams to a force, because really Hooke's law is F equals negative kx, where F is given in newtons. And so we're going to actually use something called create what's called a calculated column from my mass data. Right? So and you're going to need to do calculations later on for other more difficult calculations in the lab. So let's start here. So I'm going to go to my data menu and find a new calculated column option, new calculated column, click on that, and I'm going to call this one force, F, and I'll put it in newtons. Right? And what I'm going to do is I'm going to actually have to convert the grams to kilograms and multiply times the acceleration due to gravity to get the weight of the hanger in newtons. So first of all, I'm going to pick my mass column from under the variables tab, click mass. Now to convert it to kilograms, I have to divide by 1,000. 1,000 grams is 1 kilogram. And then let's put that in parentheses, because now I have my mass in kilograms. I'm going to multiply times 9.8, right, which gives me the the weight in newtons. So I'm going to click Done, and now I have my new column, right, which is the force in newtons. So I would like to replace that then on the x-axis. So I click on that header, and it allows me to pick a different x column. So I'm going to choose force. By the way, I could have also done this by double-clicking on the graph itself, right? Or I could have gone up to Graph Options in the upper menu and also gotten the same dialog. All right, so let's move on. Now at this point, I think I need to do some rescaling because my points are all over here on the side. So I'm going to hit Auto Scale. And yes, it'd be nice to make those points bigger. There is a way to do that, but it didn't seem to work for me, so we're stuck the way they are. But of course, from this point on, you can do the curve fit as described in the presentation for the lab itself. Just keep in mind that you're fitting position versus force, not force versus position, so your equation will have a slope of -1 over k. And that's one of the parameters you'll be looking for. In the curve fitting, you can just go ahead and close this file because all you really need is to record the slope and the intercept for your analysis. And then you'll go ahead and open a new one, which you'll use for the much larger part of the lab, which is measuring the conservation of energy using the mass bobbing up and down. Make sure that you go back and click on Connect Points, though, once you get to your new file.